Check out the flight capability of this 3D printed F-22 park flyer. This F-22 is a phenomenal park flyer, capable of unlimited vertical performance and high G turns if you follow my print and build recommendations. I couldn't be more happy with the way this airframe turned out. If you print this using the recommended print settings and the recommended motor and prop, yours will fly exactly like this one does. Having that vectored rudder is a lot of fun. It gives you a lot of control. This airframe can be built between 2 and 5 channels. The elevons are required, but the flaperons and rudder are optional. These park flying pushers will make you a better pilot, I promise you. This thing will high alpha all day long, and the fact that you can climb out of a high alpha vertically is freaking awesome. This airframe was designed to print well, be flown anywhere, and minimize construction time. All the control surfaces are hinged simply by inserting PLA along the hinge line, so you don't have to cut anything. As a matter of fact, there's no cutting anywhere on the entire model. If you've built one of my models, you know exactly what I mean. This airframe was designed to be very high performance, capable of vertical flight and high G turns, as long as you build it with the recommended motor and prop. This is now version 3 of my F-22, and I built this one using the G codes and all the build recommendations that come with the files. So if you build one of these and you follow the print and build recommendations, yours is going to turn out exactly like this one. When I started this project, I had said that I wanted an F-22 that's going to fly like an F-22, and that's exactly what I got. This thing turned out amazing. Correct me if I'm wrong, but I'm pretty sure this is the first 3D printed mid-mounted pusher with vectored control surfaces. It uses all 9-gram servos, which are completely accessible and replaceable. The airframe was designed to print without any overhangs, to minimize travel moves, and to use a minimal amount of lightweight PLA. It only requires 400 to 450 grams of lightweight PLA, so you literally can build 2 of these with 1 roll of lightweight. ASA is required for the motor mount. If you don't want to use ASA, you can screw the motor mount to a piece of plywood and glue that piece of plywood right to the back of Fuse 5. You literally can fly this airplane almost anywhere. You can keep it in a really tight space, and it doesn't take much area to land at all. I will leave a link in the description to where you guys can find these model files. The build video will be available very shortly. There is print and build recommendations available with the model files. Don't forget that this thing's made out of plastic, not foam. The fact that you can high alpha and then climb vertically out of it is freaking awesome, especially for a 3D print. The hatch has a slide lock using a rubber band. It will never fall off in flight like this. The amount of control that you get with those thrust vectored control surfaces is just freaking awesome. I didn't use any weight to balance this model. It balances with just the battery, and there's still a lot of room to go forward with the battery. I like to fly mine nose heavy because it recovers from a stall better that way. With this setup, it's got plenty of power to get out of a bad situation. This airframe will fly with different motor and prop combinations, including smaller motors. I have flown it with a 2212 and 2830. Check out my other F-22 flight and test videos to see the performance with that setup. I'd love to hear from you guys what you think about my F-22 park flyer. I've done the best I can with this airframe to test everything that I possibly can think of, and I've even tried to break the wings off. It does fly with a smaller motor, but it will not fly like this one does. Check out my other videos to see how it performs with smaller motors and different prop combinations. It was designed around a 7-inch prop. If you're going to build one of these for yourself, I definitely recommend checking out my different motor and prop combinations I've already tested and the different percent infills I've tested as well. I'm printing the fuselage and wings with 1.5% infill. In these first couple flights I was flying with a 2200 4S battery. If I wanted to get a little bit more performance out of this jet, I could put a smaller battery in it as well. If you like building and flying RC airplanes, subscribe to my channel for future build, flight, and test videos. I did print this one with the G-codes, and I built it using all the recommended settings. For these 3 flights, I flew with a 2200 battery. If you wanted to get a little bit more performance out of it, you could put a little bit higher of a pitch prop on it and fly with a little bit smaller of a battery. The Tiger paint scheme is very simple to do. It works with many different print colors. It is hand painted and added about 32 grams. Does my face always look like that when I'm flying? If you guys enjoyed watching me cruise around with my F-22, let me know by hitting that like button. I will leave a link in the description to where you guys can find this airframe. I'd love to hear what you guys think about my F-22 park flyer in the comments section. Thank you guys for watching and your interest in my F-22 park flyer, and I'll talk to you next time. That's it, no more fun. Bitchin' Betty's on my ass again. Full flaps. And she's a real looker.